guys, so we're back again for day 11, and I'm just excited because I feel like we're finally going to be getting to the end of this. Like week 3, at the end of this week, we're going to be to the halfway point, and it will be May 4th before we know it. So we're going to, as I said yesterday, we're going to continue with our work with functions, and today we're going to talk about representing functions. And you guys are going to like this because it's stuff that we've kind of already talked about and just not really using these words. So let's get to it. All right. So as we talked about yesterday, a function is a relationship between inputs and outputs where each input only has one output. We use the vertical line test and we use mapping diagrams to determine whether something was a function. And if there were two y's coming off of the same x, then we said it was not. So today we're going to talk about different ways to look at functions. We've already talked about, so let's take a look. You can look at functions as a set of ordered pairs. You can look at functions in a table of values, in a graph, or in an equation, which we've done all of that. So we're kind of just going to refresh our memories today. So let's kind of take a look what all of these look like. Okay, so during 1 hour of walking, you burn 257 calories. The total number of calories burned is a function of the number of hours you walk, meaning that two quantities are working together. That's what a function is. How can you represent this situation in 4 different ways? So as we see here in our ordered pairs, wait, where's my pen? There we go. Okay. So if you walked for 0 hours, you would burn 0 calories because you haven't started walking yet. And then each hour, you would go up to 57. All right, so now looking at that, we can put that in a table and then we can represent it on a graph. And then an equation. We know that our constant proportionality or our constant of change or our slope is 257 because as x increase as y increase, it's our change in y over our change in x. Change in y is 257. Change in x is 1, so that's a slope of 257. And there's no y-intercept because it is a proportion. So that's 257x. Okay, circle the table that could be viewed as a function represented by this, a view of the function represented by the graph. So I'm going to list out some ordered pairs here, and we're going to see if we see them. I have 0, 0, but all these tables have 0, 0. I have -1, 3. So let's see if none of those have that. Strange. I have 1, -3. And I only see one table that has that, so it's going to be option B. And then let's check. We have 2, -6. You can't really see that because it's not that far down yet. Again, option B is the only one that has the point 1, -3. So it's going to be option B is the table that matches that graph. Which equation could be a view of the function? So we need to find our slope here. We know, so if I graph this out, hold on, it's a terrible graph. If x is 0 and y is -2, that means that this is our y-intercept. Discard. Oh, hold on, guys. Okay, so we were here, and this is our last thing we're going to talk about. I want to look at here. If y is 0, so let's sketch a graph. If y is 0 and x is -2, sorry, if x is 0 and y is -2, that's going to be this point here, which is our y-intercept. And if you remember, our y-intercept is at the end, and option 2 has the y-intercept of -2. So it would be option B. It's not option 1 because that would have a 0.00, and this does not show the 0.00. And then this would have a y-intercept of positive 2, but it's negative 2. So it would be option 2. All right. Sorry for the screw ups during that last example. I hope you guys took away what you needed to from it. So that's going to be the end. Now you guys are going to go head over to Pearson and work on what you need to work on, and I'll see you on Zoom at 10. All right. Bye, guys.